All right, guys, it's time for another live stream for the upcoming update of InstaMAT. We're going to release it later tonight. I'm not sure when, but I'm your host today. My name is Manfred. I'm going to take you through a couple of new things, changes, improvements to InstaMAT, things you can expect in this build, and of course, the long-awaited integrations, plugins for InstaMAT, so you can use InstaMAT when you use Blender or Autodesk Maya, Unity, and Unreal Engine. I'm going to show you the integrations today for, I think it's going to be Blender and Unreal Engine, but we're also going to start off by taking a look at InstaMAT Studio and what's new. There's a couple of things I'm really excited about. One of those is the ever-increasing performance of painting and UDIMs, especially when you have really large projects. So let's not waste any more time because we are on a budget today. And let's take a look. Daniel, maybe you can transition over to the desktop here. All right, guys, so once again, I'm launching the latest build of InstaMAT. This one is a few minutes before we actually, bundle up the release build. So there might be some things not working, but as we launch, you see this is quite familiar. And I think one of the really interesting things maybe that you see immediately is a couple of new tutorials that I want to take you through. And I think one really important tutorial that was missing so far was actually material layering. I'm sure a lot of you guys understood how material layering works, but it's still great to be able to just open a template and see material layering live. So that's what I'm doing. So I just double click the tutorial. It's gonna start up InstaMAT Studio and load all of this, all of the layers here into my viewport, into my project. And you see here we have this really nice looking pavement material. That's a kit bash of a couple of materials in our material library, and it just looks really awesome. And here you can learn why this looks awesome. And a couple of techniques to make materials look great is to ensure that they're cohesive in one way or another, whether it's using color matching or whether you're creating some dirt that just sticks everything closer together. And here, for instance, is this AO based dirt. If I disable this layer, I'm not sure if you guys can see this, but if I get a bit closer, you can see it. This basically adds a layer of dirt over both the grass and the rocks, and it just makes things look much more closer together. And also here is a color match that basically takes this grass layer. So if I disable it, you can see all the grass is gone, and just color matches it to the pavement, because like this it looks great, but it's way too saturated for me. I mean, you could use it like this, it looks great, but if we color match it, it just looks a bit more integrated, a bit more closer together. And then we have a few more things you can explore here. For instance, how could you add water to the material without using a material effect water node? And this water layer here is entirely done within the material layering project here. It doesn't use anything super fancy besides what you have at your disposal. And a lot of people don't know that you can also use the paint engine or decals in a material layering project. So we've added those hidden layers. You can enable those, and then you'll see we have a couple of more layers here, and it's actually a decal. So I can select it and I can actually move it around like you would expect it to be moved around in a regular layering project. Or the crystals, and the crystals, if I disable this layer right here, you'll see they're now all over our material. And what's great about the material layering is it doesn't just do a comp like a regular asset texturing project, where you would layer from the bottom up and you just use masks to avoid avoid your material from being applied in regions where you don't want it to be applied. But if you do material layering, it'll do a physically based layering. So everything is based on the height. So you can see how even though the crystals are here in the middle, they're not covering the whole material, because they automatically do a very specific blend using the height information from the lower layers and its own height information to figure out how to create a mask for this. And if I re-enable this mask, you can see that it's actually masking off the area around the InstaMAT icon. And I can continue painting here. If I hit B to enter the paint mode, I can paint more crystals in my material. So it's pretty awesome actually that you can create a material that's completely procedural. So none of this is baked in if you would use other tools to do this kind of material. I can change my seed, and then the whole material will re-render. So all the procedural parts of this material are still in effect, but we can add some hand-painted parts to it, which is great because my decal will always be in the same place. So I can create a mask that always masks off my decal really nicely. I can hit E to erase here from my material if I want to, hit B to paint some more areas here. I think I can even solo this here. You can see the mask that I've painted. That's what I love about InstaMAT's layering, that we can easily solo a mask, solo a layer, and see how it affects how the mask affects or how the actual mask looks like, and not just the effect of the mask. So that looks great, and as I mentioned, I can change my seed, and it goes back to an entirely different layout, but the key elements that we painted in, they're still here. And what's also great about this material layering is that I can choose to expose a couple of parameters from, for instance, this material that I'm compositing here using my layering workflow. I could, for instance, choose to expose the crystal's color by just right-clicking and then exposing that as an input parameter, and you can see it shows up here. I could do the same for the grass. I could, for instance, control the amount of dead grass that I have here by just right-clicking and then exposing it. If I hit save, I'll save my layering project, and here you can see another great feature of the latest build. If you edit a project and you save it, it actually recommends you to use the name of the current project as the name of your package, so you don't have to type it in again. So I'll save it on my desktop. And if I go to the package, you see here's my material layering project. I can create a regular element graph project. That's the node-based workflow where you would normally create materials or asset pipelines, procedural modeling. And then here in this graph, I can now bring in my material layering project, and you can see it has those parameters exposed that I've chosen to expose, and I could add much more to it. So previewing this material, and you can see it works exactly as you would want it to work. And the beauty is you can really create really compelling materials using material layering. They're fully procedural. They have procedural elements that you can expose. All these great features that you might love about the graph-based workflow, but you can easily things together, kit bash things together, and then use the resulting project and then run it in Blender or run it in Unreal Engine. And it works just like one of those powerhouse graph-based materials. And you can see another great thing already actually, and that's that if I go back to that project here, I love the fact that we can tap from one project type to another, because that's normally like you shut down the Painter application and you go to the graph-based application. But with InstaMAT, it's all in one application. So right here on the left side, you can see that there's a new parameter here. It's the height normal strength, and I can modify this, and you can see I can now control the intensity of my normal channel. That's the result of the height comp that we're doing here under the hood. This feature is now available in both material layering and in the asset layering, asset texturing. So that's pretty great. Another really interesting new tutorial is if we go to the element graph and then we choose that mesh scatter material workflow tutorial, that shows something that's really awesome that only InstaMAT can do, unless you use like 2 or 3 applications to build it, of course. But integrated in the way that it works here, that's something that only InstaMAT can do. So what do we have here? So here we have some interesting looking material, and you can see that there's some cubes scattered all over the material. It looks pretty cool actually with those cubes sticking out of the material. And you might believe that this is procedural modeling that we used here to create that particular geometry and apply a texture. But it's not. If I disable the height, you can see that this is actually just one of those regular graph-based materials where we have height, roughness, metalness, a normal channel, and all of those things. And then when you enable the normal rendering and the displacement rendering, it just looks really, really awesome. And it's one of those fundamental building blocks of modern real-time rendering. All right, so here we see we have those cubes, but what's special about this? What can you learn in this tutorial? Well, we show how to do these really complex workflows where you would take something like a mesh and use that mesh as the basis for your material. It's very common to do this if you have something like a scatter of sandbags or bricks or some rubble that you want to have on the ground. The typical workflow would be that somebody models those individual parts in ZBrush or something. Then you would bring that to a tool like Blender, where you would then run a physics sim. And when you have the physics sim, you would load all of this into a baker to bake it down to the final displacement map and the mask map that you could use to then texture your project in a node-based graph editor to create your final material. So you don't have to do this with InstaMAT. And the beauty here is that it's very dynamic, so you can easily change the type of the scatter. For instance, if the art director comes along and he's like, you know what, we have way too many cubes on this material, you need to reduce the count, then you can just reduce the count here and you'll have much less cubes, or you could even add much more. Or somebody else might come along and say, you know what, we don't want boxes, we want to have balls, so you can just use the ball here in the enum, and again, you can increase the count. And that tutorial shows you how to do this end to end. And I just want to quickly show you a few of those key workflows and how it starts. So if I zoom in here, you can see that the graph starts right here with this enum select. Basically, this is where the user can choose what to select for the scatter, right? So if I choose, for instance, the box, you'll see now it says box here and it flashed yellow. I don't know if you guys saw this, but it basically means those nodes re-rendered. You can actually enable this effect or disable it up here in the menu if you choose to enable flash rendered nodes. It's pretty great if you want to see, okay, I changed that parameter. What changed in my graph? What re-rendered? So if I change it again, you can observe that those nodes flashed yellow. It's a great feature, but you have to be mindful about the performance. This costs some performance, so if you really need rapid re-rendering, you might want to disable it. All right, so here we select the mesh that we're using for our scatter, and what's pretty awesome is that the way we can use any mesh. So you see there's a custom mesh input, for instance, but there's also the InstaMAT icon. If I enable this, it just works. And what's beautiful here is that you see that the scatter size of the InstaMAT icon perfectly matches the box or the circle, even though the geometry size of the InstaMAT icon might be 100 units and the box is just 1 unit, and things just work. So if I would change this to use custom, again, now we scatter a different cube. I think this is our bevel cube, so this one has rounded corners. If I go back to the InstaMAT icon, again, it just works. And the reason this works is another one of the new features of this build. It's a node called Mesh Target Scale. It's pretty awesome for procedural pipelines because you can choose to match the size of one mesh to the size of another mesh. So that's exactly what we're doing here. So we take that InstaMAT icon, we do a target scale here, and we choose the shape generator which creates the box procedurally for us and match its size. And you can choose to match on the radius, the AAB size, or even specify a manual value. That's a pretty great way to make sure that your pipeline always has a consistent size for the input geometry, so those scatters would work. Because if the mesh would be now 10 times bigger, the scatter would look very different and it just wouldn't work anymore. Of course it would scatter well, but overall it wouldn't look exactly as you would want. So we take that mesh from the enum select, and then we use the set vertex color node here to assign different vertex colors. So you can see here it's red, it's green, and it's blue. And then we basically create 3 different meshes that we all feed into our drop-on topology node as different scatter meshes. And the drop-on topology node then creates for us the mesh that we want to. I'll do a mesh render depth here so we can take a look at it. So here you see that's the geometry that we created here actually. So it contains the InstaMAT icons and we scatter them on a plane, and it also contains the plane. And one of the key difficulties about doing a scatter like this and then making it tile, it's typically very, very tricky, and oftentimes artists, even when you do that workflow by hand, they use a tool like Photoshop to stamp in some areas from one side of the mesh to another one, or they try to do that in Maya directly. With InstaMAT, we don't have to do this. We can run a scatter like this, and then we can use our mesh tile node, which would automatically ensure that your scattered geometry, anything you have on a plane, would be perfectly tiling. So it's pretty awesome. So you see I use the mesh tile node, and that doesn't just ensure that it tiles, it actually also ensures that we have all the outputs that we need. So I can create my normals, my vertex color, and here you can see that each individual scattered object has the vertex colors that we assign to it. And also the UVs. That's actually pretty interesting because that's something that you can't do typically in the workflow. I don't know if you saw this, guys, but there's actually the things that we scatter, they actually have textures on them, because we use the UV output here together with the image mapper node to apply a material or a texture to the scattered result. All right, so it's the mesh tile node, and then we basically do a very, very trivial comp. Everybody can understand what's happening here. So very easy, just a bit of colors, just creating a bit of soil and then comping it all together, and that's it. So I really recommend you guys to check this out. It's super interesting. And I'm not sure if you guys saw, but with the last release, we also added a physics scatter tutorial. And here we show how you can do a physics sim. So you see here, we are basically setting up all the basics for a physics simulation. And then all you have to do if you want to run it or see how it works, you can drag the slider, and you can see on the left side on the viewport, let me make that bigger for you guys. So you can see if I change that value right here, it runs the physics sim. So I can let that pile of cubes and spheres just hit the ground like this. It would be funny to have some sound and play it with the sound. Let the balls jump. All right, guys, so the new tutorials are awesome. If you have ideas for tutorials that you guys want to see, specific workflows that are really interesting to you guys, just let us know and we'll take a look. And what's also pretty great is that our community actually helped us to improve our translations. With the last release, we added automatic translations for Japanese and Chinese, and the community stepped in and actually improved our translations in areas where the automatic translation didn't provide great results. And with this release, we can make that even better. Because if you guys want to translate for us, we can give you guys a tool, you can translate it, and then you don't need to have a special build to prove your translations. You can now load in custom translations into the latest build to make sure that everything is looking great. So this time I have cards here, so I know what I want to talk about with you guys. We're going to release a changelog that contains all of the changes, all of the major changes that are part of this release later after the live stream, once we release the new builds, and then you can look at all the details. I'm not going to cover everything in all that fine detail now. Another major feature that was requested is actually the ability to export a project. Let's see, which one am I going to export? Yeah, like this mesh scatter material here. So imagine that I want to export this or send this or sell this particular material here. It's a fantastic pipeline, contains a lot of trade secrets. And I want to sell it, but I don't want people to be able to open it and look at how exactly my magic sauce works. You can do this now very easily by using the export cooked project option up here. So I can export this project as cooked, and then I can export it to my desktop. I'll call it demo. I'll save this. And now InstaMAT asks me whether I want to prevent opening the package. And if I prevent opening the package, then we call this a securely cooked project. And that will make it impossible for people to open your project. And what's pretty great about this process is that all of your dependencies, whether it's images, meshes, other graphs, they would automatically be included in that cooked project. They get new IDs, so they won't conflict with anything that you might have in your library. So that's pretty great. So if I try to open this particular package here, InstaMAT now tells me, no sir, this is not something that you can do. This is a cooked package. It cannot be loaded into InstaMAT. So I think this is a great feature for a lot of people that want to create tools and specific features, and not make it possible to open it. This might even be something for studios if they want to be sure that their material library, when it's used in a project, it's not modified by accident in any way. So this is good for many different reasons. Another great feature, I'm not sure if I have means to demo this here. Let me see. I don't think so, but if I would just create, say I'm going to create a screen cap of this right here, it's going to save this small screenshot to my desktop, and then I'll create a package. Let's create an element graph, just like this, and I'll bring in that screenshot. Let's just rename this to A. I'll bring in that A into my package, like this. And you see now I have my image in my package here, and I can just drag it into my graph, and then here we could do something like an HSL, and then we can output this as base color, and then I'll see it on my cube very easily. So if something would have happened and this resource would have changed, you might want to reload that into your graph. This was previously very difficult to do because you must re-import it, restart, and there's a lot of things you had to do. And now you can just right click here and choose re-import if you want to re-import your asset from the imported location. So InstaMAT now tracks from which folder you imported the asset from and then re-imports it from that particular location. But if you want to re-import it from a different location, that's also possible now. So that's a pretty good feature. And I don't know if you guys notice it, but we did some small improvements here to the toolbar to better indicate which buttons are those toggles. You can see here, they have the line below the button, and which buttons in the toolbar are just buttons. So that might seem minor, but I think it's going to be a great help for anybody new to InstaMAT. Another great feature a lot of people are really going to be happy about, I believe, is the ability to use native file dialogs. So if you now open a file or export a file, you get OS native dialogs. This means you get your stock Windows file browser on Windows, you get your stock file browser on Mac. And there's of course much more here to say about what's changed in the overall application, from improvements to the image viewer to improvements to the auto updater. Many people asked if we have an auto updater. Yes, we have an auto updater, so InstaMAT will recognize if there's a new build and ask you to install it. We actually had to disable it because we had some issues on some systems, some Windows versions, and we wanted to make sure that people are not being confused by InstaMAT wanting to update and update itself, even though it was already on the latest build. So that's something we removed and improved. There's a huge amount of new nodes actually for meshes and procedural geometry in InstaMAT. A lot of those I think are going to be game changers if you work with procedural modeling. So let's use the mesh shape generator to quickly create a mesh. So this is just a sphere here. We can control the radius of our sphere. We can control the segment. So that one isn't new actually. This is an old node. But something we can do now with the new nodes is use something like set normal or mesh set vertex normal. So you see we have a lot of new nodes to set vertex attribute data from the colors to the normal. So if I use this node, I can choose, I can specify a texture, and we would sample the texture at the location of the vertices and then assign those as vertex normals. That's a pretty interesting thing if you want to bend your normals into a very specific way. I already showed you guys the target scale node, which is pretty awesome, where you can have one adapt the size of one mesh to another mesh, so that's pretty great. Another really interesting and sophisticated node would be transfer attributes. So mesh transfer attributes is you can basically, perform a raycast or closest point source on another mesh and then take the attribute from that closest location you find and then adopt it for your mesh. So you could use UVs, colors, or vertex normals from a different mesh. A pretty interesting node in InstaMAT for really complicated procedural workflows. And there's a new way to work with meshes, even using the ability to have arrays. That's also something we added in this build. So if I search just for array, you'll see we have a huge amount of different nodes here that allow you to modify arrays, basically sets of numbers. And you might wonder why you would need this, but there's some pretty great things you can do with those numbers. So let me zoom out here again and focus. So one of the things that you can do here, for instance, is to use a node or one of our new select nodes where you can, for instance, select a set of polygons based on the direction, the normal, or you can select them based on a volume. So if I use this node right here, and I'm going to preview the mesh like this. So with that select node, I can actually use the gizmo to select a specific range of polygons from the mesh, and that selection would then be stored in one of those arrays that I just showed you guys. So in this case, we have the polygon array, and I can do something like array length. And you see this array contains 200 entries, and then you can transform it further by doing things like extracting those polygons or deleting it and passing to that node. You see here, delete by polygons. So you could then pass that selection to this node in particular, and it would delete. You can see here we have 1000 polygons, and then here we have 208 less, so it's 848. And up here you can see we deleted those polygons. But you could also use that for something entirely different. You could do something like extract by polygons. So if I pass the array to this node, we'll actually just get the exact selection that we extracted here. And what's pretty fun if you go and select that, for instance, and I select my volume, I zoom out. So I view the output of the delete by polygons, but I selected the select polygons by volume node, and you can see, I don't know if you guys can see this, but I can now dynamically move around and adjust my selection. I don't have to use a box, I could use a sphere. You see now I can cut out the polygons from my mesh. So it's really interesting things, and you can keep refining the extraction, or whether it's using an extract or delete and continue working on like this, but you can also use the polygon array and do something else. And I think there's a node where we can use polygon to vertex selection. So if I use this node, it gives me a different array, and that array now contains all the vertex information or the indices of the vertices that would be part of that polygon selection. And again, you can do interesting things like change the vertex colors of that particular selection, or change the normals or anything that you would want to do. So there's a huge amount of different new nodes for procedural modeling. Another wonderful node, many people don't know that this is possible, but it's pretty great, is that you can use the paint engine when you do a graph-based workflow. So here's my sphere. I'll take that, plug it into mesh painting, and you see the node doesn't have any outputs. And the reason is that it's a very dynamic node. It's the entire paint engine in a single node, and you can configure it to have as many channels for output as you want to have, and it's still fully procedural. So it doesn't store pixels in the node that you modified. No, it stores all of the encoded paint strokes in the volume. So when you want to add a new channel, you can just do so. If the geometry changes, you can just change it and everything would work. So right here, I'm going to add a new channel. I'm going to call that base color. So this is a color channel, and let's just plug that guy up here into this. And if I select my mesh and I go to the viewport, you can see I can actually just paint on my sphere just like this, and everything just works. And what's pretty awesome is you can change the geometry. So for instance, if I change that to be a box, the paint strokes would just adjust automatically. You can see it paints here perfectly. So, and the reason that it's a bit darker here on the outside is because we painted on the curvature, and the position of the curvature actually doesn't exist on the mesh. But it's still pretty wild if you think about it, that these strokes are all perfectly applied. The UV is entirely different, but it still works. So if I go back to my, what did we have here? A UV sphere. You can see that the result of the paint output here is very different, but it just works. This really has phenomenal potential to use in a pipeline, whether you want to mask specific regions or add some paint to it, project something onto it. Because you have all the features, you can even use the paint projector to paint on that particular section of the mesh. So like I mentioned, there's a huge amount of improvements to the canvas. I can't really dive into all of those. I think another one that's pretty interesting is actually the hex nodes. So we added hex to color, where we make use of the string functionality to convert a hex value to a color value. That's pretty interesting. So hex colors are typically used on the web. So if you just take a color from some website, you can now plug it into that node and it'll actually give you a color output. So I think that's pretty interesting, and it shows the things that InstaMAT can do. And you can even take a color output and then convert that to a hex output again. It's pretty nice. We also added a couple of new nodes, like, what is it called? I think it's called triangles tessellated. I think that's the new triangle node, where you can create a dynamic set of very interesting looking irregular triangles. You can control the density of the grid. You can render it as lines. You can even render quads if you choose to do so. And what I like here is that it can also create a flood fill, so it makes it very easy if you want to apply textures or use something like the flood fill to corner to transform the output. I think that's a pretty interesting node to have. And there's also another one that I like. I think it's called symmetry line, and that's like a mirror modifier for 2D. So we can basically mirror our image over a specific edge, and we can rotate that edge or the line, and it will mirror over that line, and we can also move the line around. So I think that's a pretty interesting node and very intuitive to use when it comes to doing those symmetric shapes. Another really great thing, I believe, for users is that we simplified our blend node. Our blend node is super powerful compared to other tools, but we wanted to simplify the user interface. So it still has all of the same great features, but we moved a lot of those features now into a advanced category. So because we noticed people are sometimes confused with all of the different modes for the background alpha, the placement. So we moved all of those into advanced, because you don't really need them in a regular, just material comp workflow. So this is much easier now, where you can just simply select the blend mode you want to use without being confused by all of the powerful features that InstaMAT has to offer. Something that I also love really is the ability that our both levels and curves node now have the ability. So if I change something here, I'll move the midpoint, black point and the white point around. It's very different. What's really nice is that you can now control the opacity of that operation. So if you feel like that looks good, but it's a bit too intense, you can dial down the opacity. And it's really great to make sure that the result you're getting looks exactly like you want it, because it makes it easy to control the intensity of that particular process. What's also great is you can actually expose that as an input parameter. So you can, if that levels node is really important for your material that controls, I know, the intensity of the grass around a stone, you can just expose that opacity slider like on a blend node, and then the user can easily modify it like this. So that's pretty great. So a lot of changes here, but let's go to the layering and see what's new for layering. So as I mentioned, we have just fantastic performance improvements for the Paint engine. It's really, really amazing, especially when you're working on a more constrained machine, less VRAM, but you still want to do UDIM texturing. in these cases, InstaMAT will perform even better. It's really aggressive when you do UDIM texturing. So I think that's pretty phenomenal. Let's see if you guys have something on the chat here. If you guys have any questions, just make sure to repeat them often enough in the chat, so when I take a look at the iPad here with the chat, that I can actually see those questions. I don't see anything here, so I'll just proceed for now, guys. All right, so here's our sample project for InstaMAT. It's the layering, the InstaMAT crate standard setup for our layering here. A feature that has been requested very often is the ability when we do a projection for our paint. Say I'm going to create a layer here, and I'm going to use a material, some wood. And actually, we don't just want to have a layer like this, but actually I can show something else with this. So a feature that was often requested, but that we didn't really like so much, is the ability to mask an area based on UV shells. The reason we didn't like it is because normally you would rasterize a mask based on the current UV shells or the UV layout. And if it changes, your mask is broken. And we figured out a way of how we can do that better. And it's here now. So you can see I can mask this off by using the mesh UV shell to mask. I'm not sure if you guys can see that. And if I use this mask, I now have the ability to pick UV shells. So I can click that button, click on my mesh, and I now have masked a UV shell on my mesh, and you can see it looks pretty nicely aligned with the UV topology. So that works pretty well, and I can not just pick a single UV shell, I can click that button and I can hold down Shift while I pick. So I hold down Shift and then I can keep selecting those areas where I want to add a mask on my object like this. And if I'm done, I can just hit Cancel Mesh Picking, and there you go. We've created a UV shell mask. So what's different here is actually that we're creating this mask not just based on the current topology that we bake into the project. What we're actually doing is we're creating sampling points in the normalized volume that we use to make those layering projects scalable. And then when we render the mask, we're basically finding the UV shells that belong in those points. That sounds very simplified and easy, but it's actually much more difficult to do in reality than you might want to believe. But fundamentally, you can just then specify a tolerance for the pick in case that the next mesh that you use might be a bit different and the tolerance to the pick must be bigger. But this picking that we just did would basically be dynamically procedurally evaluated by InstaMAT and then applied as a mask. All right, so that's one way to mask. I'll disable this mask by just deleting it. And then I'll create another mask. So this one is part of the favorites that you get when you install InstaMAT. We set up these default favorites. You can always add your own nodes. There's another one that's a bit more advanced, and it's the polygon mask. So I'm creating the polygon mask here. And this one is similar to the UV mask. You can mask individual polygons, but instead of picking a point, you can move a volume around. And that could be a box, it could be a sphere. And that volume could also be scaled up and down. I don't know where my scale is. Let's reset that. So that should work if I scale it. I'm not sure why it doesn't want to scale perfectly. But normally we should be able to scale. So I think there's something that needs to be corrected here in this build. So let's reset the position, reset the scale. And here we go. Let's try it again. Nope, it doesn't want to scale. Something's wrong with the scale gizmo, I would say. But if I increase the scale to 0.2 and we move the gizmo to the front, you can see it actually works. So it's not really an issue with the node. It's an issue with the gizmo. But if I move this around, you can see I can now easily define an area of polygons that I want to have masked, and every polygon that intersects this 3D volume would then automatically be masked off. And again, the benefit of masking polygons this way and not just picking them is that we can easily re-evaluate if the topology changes. So that's pretty great. So this lives in the normalized volume, makes it very versatile. So there's a lot of improvements here in the layering engine. I recommend you guys to check out the changelog to see all the details. There's a huge amount of stuff, but I believe the high points really are the ability to use a UV shell as mask or use individual polygons as mask. Another great feature, I think that one is worth mentioning too, is the ability when you paint and you have back faces enabled. I don't know, let's try and see this one. Let's disable this guy right here. I'll create a element brush, And this time I'm gonna use my wood once again. So if I go into my crate and I would paint here, previously it would paint on the box even though you don't see the polygons. And what's pretty great now is that you can actually, you know, enable backface culling in the viewport, and then you would paint on the back faces or not, depending on your setting. So that's a pretty nice feature. Another great feature is if I enable the projection here, I don't know if you guys can see that in the stream, but we have the overlay of the projection, and if I paint here, I'm basically projecting my values onto the crate that are from the screen projection, not just from the stamp application. Another great feature in this build is you have this rotation icon here. So if I click that rotation icon, I can now choose to rotate my projection in any way that I want. So if I want the wood to face downwards here on the sides, you see if I paint over it like this, we now get the wood to be rotated downwards. So this allows you to easily control exactly how the projection works. If you want to have the wood go down or to the side, you can just rotate the gizmo right here and we would do that change for you automatically. So that's a pretty nice feature as well, I believe. So let's see what else we have in our cards today. There's quite a lot more to show you guys in those cards, but I think we have to move on and take a look at the integrations because there's only like 20 minutes left. All right, so I'm closing down InstaMAT Studio, and what we want to achieve with the integrations is to allow you guys to use the projects that you've built, but not just within InstaMAT Studio or InstaMAT Pipeline, but actually use all of those projects, the graphs that do procedural modeling or the graphs that create beautiful textures, and use them in Unity, Unreal Engine, Blender, or wherever else you might work. Let's start off with Blender. So here's Blender 4.0 on this Mac, and I'm not the best Blender user, so I hope I'll be able to navigate around. So in order to install the InstaMAT integration, all you have to do is point Blender here with the add-on setup to the zip file that you'll be able to download later today, and then it's going to be installed. And then the next thing you would have to do is, let's go to shading already here, is hit N, bring up the sidebar, and then here's a new tab for InstaMAT. And that's a pretty great tab because it allows you to browse all of the material library that you have available, whether it's on graphs that we have in InstaMAT Studio, one of those 1000 materials, or it's your own library, you'll be able to find it here. And I think the integration looks pretty nice here in Blender with those different previews that you're used to from InstaMAT Studio. We can search by category, or I can just enter something like dirt road, and then here's the graph that I searched for. I can just hit the play button to select that graph, and now the integration asks me whether I want to connect that to the current active material, which I think is pretty great, and it offers me a name for the instance. So I'll just click create here. InstaMAT is going to render in the background and then automatically set up the shading network. At least I hope it will do that. This whole process is pretty tricky. Let's see if it did what it should do, and it did actually, so that's pretty nice. So you can see that here we have our material on the cube. The UVs are not so great, so we might be able to, let's see if I can create a plane. Like I said, I'm not the most sophisticated Blender user out there, so I'm going to choose to create a plane. I'm going to scale it up a bit, select the cube, I'm going to delete this guy, and then let's see if I find a way to assign this material like this perfectly. So here you guys can see we have assigned the plane, material to our plane, and that is a material that looks exactly as it would be rendered in InstaMAT Studio. And what's pretty great about this is if you work in Blender, you have access to thousands of materials with unlimited different variations. So if I hit N again to bring up the InstaMAT integration, you'll see that I have all of my settings here. So if I want to flood the material with water, I can just increase the water level, wait a few seconds, everything renders, everything is reloaded, and you see now we have a lot of water here on our material. That looks pretty great, like this. And if I want to change a few more parameters, I could reduce the water level, change the ground color, change whatever color I want. But you see, as soon as I change a parameter, it re-renders. I mean, it's pretty fast in rendering. It's InstaMAT after all, right? But if I want to change multiple parameters, I can just choose to set the update type to manual full resolution, and now I can do multiple changes. So I could choose to remove the track count altogether, I can remove the water level completely, and then I can maybe increase the grass density here. I can increase the hay by just dragging it. And once I'm ready with my changes, I can hit update instance, and then InstaMAT will re-render that instance, update the shading network, and there you go. That's how easy it is to use InstaMAT here in Blender. I think it's a very powerful tool to have. You can quickly create beautiful renderings without having to worry about materials. Everything is going to be here. Your user library, all of those thousands of different stock materials. If you want to render it at a higher resolution, you can easily go to render this material at 4K by 4K. Then we can go back down here and click update instance. It's gonna re-render. What's also nice is that it's gonna render those textures to disk, so all of your information is easily available. You can package it, send it somewhere, and the settings for your instances, they're not just in memory. They're not just gonna be gone when you close InstaMAT and start it back up. It's actually gonna be stored in the blend file. So if you load the blend file back up, we're going to try to reconstruct all of your instances and all of the settings. So here we go, we rendered this at 4K now within, that looks pretty awesome, with all of the detail that you can see here on this material, with all of the hay. So that has been rendered directly in Blender very easily. I hope it works well. Let us know what you think, guys. This is pretty early days for us with the Blender integration. There's still a lot of things that we can do with it. I think you should be able to process meshes as well at some point. So if you want to extend your geometry nodes with InstaMAT functionality, or you have a really, fantastic asset pipeline that you want to run directly here in Blender, it's something that you can do. All right. So let's take a look at Unreal Engine. So I'm starting the launcher here. I need to go through the launcher in order to even be able to start the engine. And that's what I'm trying to do here, launching the engine. Setup for the Unreal Engine integration is very similar to the Blender integration. All you have to do is install the integration based on how we describe it to be done. And then the next thing you have to do is point it to the installation folder of InstaMAT Studio, and then you're ready to go. Right, so this is launching. I hope it's not compiling too many shaders, but it seems to be working pretty well. All right, so here we have a sample project for Unreal Engine, and you can see that this should just work if I play. Yes, everything just works. All right. So how do we use InstaMAT within Unreal Engine? So once you install the plugin, which is mostly just drag and drop into your project and then recompiling the sources, you'll have the small button up here in the main toolbar. It's the InstaMAT menu where you can bring up the settings, your default settings, the memory budget, where you installed InstaMAT, license info, and all of these things. Again, it is necessary to install InstaMAT Studio, so make sure to install Studio first before you install the plugin. And then you even have the library browser right here, which is pretty nice. You can easily navigate through all of the different materials that you have. And the UI and the UX, we tried to make that as familiar to you as possible. So you have a very nice looking browser here where you can see beautiful previews of those graphs that you have available. We use the pre-calculated caches in both Blender and Unreal Engine, of course Unity 2, from InstaMAT Studio, so the integration doesn't have to re-render all of those beautiful previews. You can just display them without wasting time in computing them. And on the right side you have all of the parameters that you have on the graph with their default values, so it makes it very easy to understand, okay, this material gives me these options to use. All right, let's try and see how we can do something here. So up in the search, I'll search for dirt road. It's the same material that we just used in Blender. And once I hit import graph, it's gonna bring that graph into my project. I'll just choose any location. So that computes the base data that Unreal needs to take this process a bit further for us. At this point, I'm gonna close down the browser, and here you can see we have that material, that InstaMAT graph now in our Unreal Engine project. But to create a material, there's one more step necessary, and that's creating an instance. So I'm right-clicking it and I'll choose Create Instance. I can give it a name. I'll just use the default right here. And that now creates basically the material, setup, the shading graph, and it also creates all of the basic functionality that I need to modify the parameters, and that would be this guy right here. So you can see there's this. This one is the material instance that controls all the settings that are Unreal specific, and then this one is the InstaMAT instance that controls the parameters that will be used to render the Unreal Engine specific material. So I can just take that material now, it's now a standard material, and I can drag it and drop it onto my Unreal Engine project, and you see that looks pretty interesting already. It's gigantic, and because that's a common issue, we added a lot of nice features to our standard material. Of course, you can bring your own material and use the textures and then load them into your own material graph, but to make things easy for most users, we just create this nice default material, and here you can see I can override the UVs like this, and that looks a bit more reasonable. There's many more things you can do. I think you can enable displacement and other features in the material. Let's see, we have enabled it's using nanite displacement already, and I'll just keep it as what it is. All right, so let's get a bit closer here again, and you can see this material looks really nice. It has all of those details that you want from the material. It's being lit properly, and in order to modify the parameters, I can just double click my node right here, and if I want to remove the water level or increase it, let's increase that first. I can just increase it, wait a few seconds, and Unreal Engine is doing a super fast re-render. We really tried to make this as fast as possible, so you can see I changed the slider, wait a few seconds, and it updates almost immediately. The performance of InstaMAT in Unreal Engine is really great at this point. So I'll remove all of the water, and if I go back out, it looks great, but I don't want to have all of those tracks here in the material that makes the tiling a bit obvious. So I'm going to remove the tracks like this, wait a few seconds, and there you see they're gone. So this is actually rendering at 2K super fast. It really shows the performance of InstaMAT here in Unreal Engine. But actually, you know what, let's re-enable the tracks. I'll bring them up to 100% again, because there's something really awesome that this material can do. And this material can't just use those straight tracks to render where the car drove through. You can actually bring your own image, and then it would use that image as a mask to render the tracks. We can even do that here in Unreal Engine. And the really awesome thing is that you can use Unreal Engine resources to drive your mask. So I'm gonna enable the use custom tracks pattern, and you can see that we now have here those tracks being rendered using the InstaMAT icon, because that's the default input. But I can also click, I think I can click here on this image, or here on the browser. It brings up the Unreal Engine browser. So let's just take something that's Unreal specific, like this Unreal Engine logo. I'll plug it in here, and you'll see it just works. So that's pretty awesome how InstaMAT is able to process Unreal Engine native assets. And it's not just images, it's also meshes and other asset types that InstaMAT wants to process. I think that's pretty great. All right, then we could control the depth of these tracks, and all of the features would still be at your disposal. So if you just want to hint at Unreal Engine being used here, you could do that, or you could revert that and don't do anything. So let's go with it like this. All right, that's great, like this. Oops, that's pretty fast mouse. So I'm going back to the content, and if I want to create another InstaMAT material, I can go back to the library, and then I can choose to, what do we want to spawn here? Maybe, yeah, why not some wood? Sci-fi panels, those look interesting. Let's just use the sci-fi panels. Again, I click import graph, choose where to save the asset. It brings the project into Unreal Engine, and then from this point on we can easily create our local material instance by right-clicking and choosing create instance. All right, let's go. This creates all the textures, all the assets, all the materials for me, and then I can just simply assign the material to any surface where I want to see it. So let's wait a few seconds here for Unreal Engine to catch up with the preview generation. I'm not sure how long that normally takes. Well, now it's computing the shaders. That's my worst nightmare here in Unreal Engine, computing the shaders and the caches. All right, so here we go. It created all of the previews. So let's see where we put this. Maybe put it on this wall like this. All right. And here you can see that the UVs of this particular world is not so great. It's pretty stretched, but like before, we can just double click this material and then maybe improve the UV distribution to make that look a bit better on our surface. But as it looks, I think this the world geometry is not really well suited here for tiling textures like this, but we can try, I guess. Yeah, but here you have the material. It's looking pretty great, and we could do all of the things that we would want to do to this material. I think it might be better to create something, just a regular rock surface or something like this, so the tiling is not so evident. Again, it's super easy to create textures, so I can just go to the library. I can search for concrete like this and take any of the concrete materials that I like. Maybe this guy, import the graph, open it. It creates the project, and then once I have the project in my project, the InstaMAT project in my Unreal Engine project, I can create as many instances. I'm not limited to creating just one instance. From one InstaMAT project, I can create as many instances as I want to set it up in any way that I like. So here you go. Now we have, that already makes much more sense. So let's apply that material here and on these other walls, just like this. And we can quickly texture our scene. It's very basic, but why not? It's probably a better way to apply many textures in Unreal Engine. I'm just not aware of it. All right. It did the job. We assigned the textures. And if I hit play, I can play my simulation here. And everything just works. Yeah, so these are the integrations for Blender and Unreal Engine. There are more integrations that are going to be available later today. It's gonna be Blender, Unreal Engine, Unity, and Autodesk Maya. Let us know how this goes for you guys. I hope you have fun with this release. I think it's a great step forward. There's a lot of new features, a lot of improvements, a lot of corrections, and also the integration. So I think it's a great day for InstaMAT. Thank you for tuning in today, guys. I hope you have a nice day, and talk to you later.